If you look at the modern workplace, you might expect algorithms to be taking over everything, but a look at the data shows the opposite. Between 2016 and 2024, as automation expanded, tasks requiring intense human interaction increased in frequency. The World Economic Forum projects that AI-driven transformation will create a net gain of 78 million jobs by 2030. The disruption adds roles rather than simply subtracting them. This is a line graph tracking productivity growth across 6 continents. For industries with low AI exposure, the line flatlines. But for AI-exposed industries, productivity growth is nearly quadrupling. Workers who integrate AI into their workflows now command a 56% wage premium. Yet most corporate AI deployments still underperform. Whenever we look at the budgets going towards these new technologies, a massive imbalance appears. 90% of those budgets go straight to the tech itself, leaving just 10%. This lopsided investment cleating to automate their way to the top often find themselves stalled. The economic bottleneck is the lopsided investment that ignores the training required to actually turn software into productivity. Think of AI capabilities as a landscape divided by an invisible line. On one side, the algorithms execute perfectly. On the other, they fail entirely. To map this frontier, researchers at Harvard Business School tested 758 consultants at the Boston Consulting Group, observing exactly where the technology succeeds and where it breaks down. This spatial map visualizes the findings. Inside machine capabilities, consultants using AI finished 25% faster, and quality jumped 40%. But crossing into tasks outside AI's limits, performance plummeted. Over-relying on confidently wrong algorithms caused a 19 percentage point drop in quality. AI cannot replace human judgment. Knowing exactly where this boundary lies and knowing when to cross it is now a critical leadership skill. Researchers at MIT Sloan define the territory outside that boundary using the EPOCH framework. That stands for empathy, presence, and opinion, creativity, and hope. These are the specific domains where humans remain irreplaceable. Take human creativity. It relies on our brain's biological ability to dynamically switch between 2 networks, the default mode network, which handles daydreaming, and the executive control network, which evaluates those abstract ideas. Current AI architectures lack this mechanism. They operate as default mode-only decoders. They can recombine existing patterns, but they lack the internal evaluator required to drive a genuine breakthrough. At scale, this mechanical limitation has a distinct consequence. AI-generated creative output homogenizes over time, reducing the collective diversity that organizations need to innovate. We see similar limits in healthcare. AI can instantly generate unlimited, cost-free empathetic responses to patients. Yet UC Berkeley researchers found that this digital empathy fails to improve patient adherence. Trust remains the biggest predictor of whether a patient follows a prescription. The effectiveness of empathy relies on signal value. A patient needs to know that a conscious being is choosing to expend effort to care for them. These traits represent biologically grounded competitive moats. Because algorithms lack the specific neural architecture for judgment and empathy, these human capabilities remain the most durable assets in an algorithmic world. The professionals who master this hybrid frontier generally adopt one of 2 profiles. They act as centaurs, strategically dividing labor, or they operate as cyborgs, maintaining constant interaction with the AI at the subtask level. Both profiles rely on a cognitive skill called data sense-making. This is the ability to interpret the context behind the information, rather than just crunching the raw numbers. Without sense-making, data is dangerous. Between 2007 and 2012, BlackBerry executives celebrated as device sales grew from 8 million to 77 million units. But because they failed to contextualize those numbers against the explosive growth of the broader market, their actual market share crashed from over 50% to under 10%. To get reliable results on the edge of the AI frontier, you have to treat prompting as a strategic communication skill. Frameworks like RACE, which stands for role, action, context, and expectation, force you to dictate exactly how the machine should behave. High-impact habits are highly specific. Assign the AI a professional identity before giving a command. Use the Ask Me Questions constraint so the machine identifies what it needs first, and ask for 50 ideas instead of 10 to push past the most common patterns. Technical coding skills are secondary. The true advantage goes to those who know what to ask and how to guide the machine with human context. The external world is now changing at roughly 3 times the speed of Moore's law. That constant technological disruption takes a heavy psychological toll on the workforce. To adapt, professionals are applying Nassim Nicholas Taleb's concept of antifragility. Antifragility describes systems that grow stronger under stress. In a career context, this means using the volatility of AI evolution as raw material for professional growth. Taleb recommends a barbell strategy for adoption. Protect your core, stable human expertise on one end, while simultaneously placing small, highly volatile bets on AI experiments on the other. In this innovation process, mistakes function as informative results. They provide the necessary data to refine hypotheses and scale the AI applications that actually work. Deep domain expertise remains the ultimate filter for AI output. While software increases the speed of production, humans provide the intention and strategic judgment that makes the output valuable. That hybrid advantage is the only durable path forward.